Hi everyone, welcome to the 10th session of confusion matrix. In this session, I'll show you how to compare the multiple classifier using confusion matrix. Generally, in case of the machine learning, when we want to present the data to the business, accuracy score is not sufficient enough. We also need to provide the precision recall, F1 score, log loss. Then you also need to provide the ROC curve, AUC curve data, so that based on that proper and the best decision can be taken. And also, we will not only provide the data for one model, we will provide the data for n number of models. I'll show you that in this video. So let's start. So what I have a data set which has 10 columns and 150 rows, and I have y which is a binary which has values either 0 or 1. See, what we'll do, we'll import the matplotlib, and then we will import all the different classifier like k nearest neighbor classifier, support vector classifier, MLP classifier, Gaussian, then decision tree, random forest, and the different type of metrics that we want to use in our program. We'll execute this, and after that what we'll do, we have the classifier. So we'll create a list of classifier. So this is our list of classifier: nearest neighbor, linear, support vector machine, RBF, SVM, and then like Gaussian process, decision tree, and random forest, neural network, AdaBoost, naive Bayes, and QDA, quadratic discriminant analysis. So we'll also execute this. Okay, so we have created a list of our classifier name. After that we'll create an object for each and every classifier that we want to create the metrics for, different metrics like precision, recall, accuracy score, F1 score, and others. So we will again execute this and keep a list ready so that when we run a for loop we will not have problem. So directly it will be very helpful. Then what we'll do, we'll create a X train. We need to do the sampling, right, comma y test, and we have already imported this from sklearn.model selection, import train test split. So we will pass the values in train test split, my x, my y, test size I'll give test underscore size, I'll give 0 point, and after that I also give the random state at 1. See, random state, and regarding about this train test split, I will mention the link in the description so that you can refer it. Random state is equals to 1. Okay, what I will do now is I'll create some model columns, because in my model column I will when I'll run the for loop, it will be added. So I'll say a list of model column is equals to empty list, and then I'll create a data frame. Data frame is equals to model column. Okay, we will execute this, and row index is equals to, will give 0. When I'll execute this, you'll understand what I am trying to achieve here. After that, what I'll do, I'll run a for loop for name, comma, classifier in. We'll give a zip. We'll zip both the names and the classifiers. See, I have already defined the name and classifier, right? Names and classifiers. So this will be mapping. When we run the for loop, and if we give the zip, names and the classifier will map. Nearest neighbor will map to k nearest classifier, linear SVM will map to SVC. This. So one by one it will be classified. I'll also provide the link of my zip code of how it works. Okay, and then after this, what I'll do, classifier clf dot I'll fit. Okay, and then what I will fit, I'll fit x train comma y train. That's how you need to fit the your model, and then I'll provide df.loc, and then what I will give, I'll pass the index. Okay, and the first column will be classifiers, which is nothing but, which will be equals to name of my classifier. Okay, whatever name it will be, my df will be created which will have the name. After that I'll pass df.loc, and then I'll pass the index again, and then I'll pass the train accuracy, suppose. Okay, I'll pass the train accuracy, and then I'll give the score of my train, clf that score. In this I need to pass the x train and y train. Okay, now and then if we run it, we need to increase the index plus equals to 1. Now if you execute this, what will happen? Okay, we have not executed this, so if you open this df, okay, now we have the classifier. We have if we sort it, okay, or in the descending order, The best classifier is, but it's for the train, it is 100%. This is for, it's not the test accuracy, it's a train accuracy. Now after that we have the neural network adder boost, and it's in the descending order. Now I'm not happy with only the train accuracy. I want to add the test accuracy also, because then only we will get the proper understanding. And not only that, we also need to provide the precision, recall, F1 score. Even after that, there are multiple metrics that you need to work on, so that we get a better insight. We'll give y-test here. Now in case of see, after this we'll provide the precision. Okay. So precision is present in precision score, which we have imported here from sklearn.metrics import precision score. So we'll give precision underscore, and then here we will pass in the precision underscore. If you see my confusion metrics entire playlist, the parameter of the precision score will be y-test and the y-pred. So what we will do, first we will pass the actual y, the y-test, and then the predicted y. Okay, so clf dot will give predict, and then what will pass, x underscore test, because we need to calculate for the recall also. Okay, here we'll give recall, and after this we will give f1 score, and then similarly index is 1. After this we'll give okay. So once we are set with our code, we'll run right from the beginning, where we are creating the df, and then we'll execute this. So the df it is executed fine, and now you can see if you want to sort it based on the accuracy, just click here. It is sorted on the descending. Again click here. It is sorted now in the descending order. Previously it was ascending order. Similarly, if you want to display based on the test accuracy, whether it's ascending or descending, we can click it there. But if and you can see here, like we have this different classifier, and we have the train, test accuracy, we have precision, recall, and the F1 score. Now even after this, what matters the most is the visualization. Okay, how you can convince your business, how, it's up to you. Okay, so if you want to do that, then it's also very simple. So what we'll do, we'll import the seaborn, and then we have the classifier, like the x column is a classifier, because if you see here in the df, this one of this column will take as a classifier, and then we'll map it. See, we'll map the x column, the classifier, with train accuracy, with test accuracy separately, with precision, with recall, with F1 score separately. We will map, not together. So here it will be, so you can see here, this is nothing but the model train accuracy comparison. Right now, similarly, if you want, you can create a for loop yourself. That's a like assignment if you want to do, and then you can create here test accuracy, and then you change here model test accuracy. Okay, so you get the test accuracy. Similarly, if you want to print for the precision, recall, and F1 score, you can give this similar thing here. But be sure your column name should matches whatever is present in this. Okay, the precision, recall, whatever you have given, it should match exactly the same. Otherwise, you will face the error. For train accuracy is done. For test accuracy is done. Now we'll print the visualization for precision, and then we'll say model precision comparison. After that, we will do the model recall comparison, and then we also need to change the column here. Y is recall. For F1 score, we'll pass F1 S score, and then model F1 score comparison we'll give here. So we'll start now with precision, executing this. Okay, so this is my model precision comparison. So you can see the best is quadratic. The best is which one? The quadratic discriminant analysis. After that, if you want to we will run for recall, the visualization. In this case, random forest is the best model. Now if you want to see like execute for F1 score, then in that case again random forest is the best. In case of precision, quadratic discriminant analysis the best. In case of test accuracy, my random forest and QDA is good. In case of train accuracy, we have so many models, like we have our support vector machine RBF, then decision tree is okay, neural network is good, and the adapters is also good. So it's up to you how you prepare and how you show it to your business. Okay, so that's it for the session. We can compare different model using the confusion matrix. Please note, I have not shown you the rock curve and the accuracy curve as part of the confusion matrix playlist. That I will only be coming up, that I'll only show after I create my logistic regression, which is in progress, and I'll be coming up. And before that, I'll be my session for gradient descent is almost done. So within a week, I'll be publishing my gradient descent, all the three gradient descent for normal gradient descent, stochastic gradient descent, and the mini batch gradient descent with code, how it works, and visualization, how we can visualize. That's it for the session. Thanks a lot for watching the video. If you feel this video is well helpful, please press the like button and subscribe to this channel. And also, if you have any friend like who is interested in analytics, you can also refer my videos and my channel. Okay, so I'll see you in my next video that will be related to gradient descent. Okay, thank you.